Hello and welcome to part 2 of lesson number 2 in Unit 1 Linear Systems in our grade 10 academic math class. It's investigating intersecting lines in linear systems. In the first video, we looked at the 3 different ways that lines can interact in the coordinate plane. And we came up with the 3 systems and their associated number of solutions. First one was an inconsistent system, meaning that we have 2 lines that are essentially parallel. There's no solution, they're never going to cross. Those 2 lines have the same slope but different y-intercepts. Then we looked at a dependent system, which has an infinite number of solutions. Essentially, it's just the same line. So it has it's all intersection points that has the same slope and the same y-intercept. The last way that they could interact is called an independent system, which has one solution only. And if we're looking at those 2 lines, their defining characteristic is having different slopes for those 2 lines. As long as the slopes are different, doesn't matter what's happening with the y-intercept, as long as the slopes are different, then we know we have an independent system that will eventually cross in one place, and that one place is the one solution. So, how do we use this? Well, in looking at linear systems, sometimes it's helpful to be able to make a prediction, or I guess not a prediction, but to know in advance how many solutions you're going to have. Will it be 0? Will it be an infinite number of solutions, or will there be only one? We won't know what the solution or solutions or lack of solution is, but we'll know what it's going to be. So here's what we're going to do. Given these linear systems, we are going to express each equation in slope y-intercept form, if necessary, to change it. Then we're going to state the slope and the y-intercept of each of the equations, and then we're going to determine the number of solutions and the type of system. So the first one I have completed. So let's just take a pause, take a moment here. Can't zoom in a whole lot and keep it on the screen, but I'll zoom in a bit. Hit pause here, copy it down, and then I'm going to talk you through it before we do the next 2. So do it now. All right, now you're back. So we have y equals 2x plus 1, y equals negative x plus 7. We have 2 equations. They're both already in slope y-intercept form. So for us, it's just a matter of getting the slope and y-intercept. So as you'll recall, the slope, or rather the y-intercept, those are the constant values at the end, and the slope, the coefficient on the x value. So in equation number 1, we have a slope of 2 and a y-intercept of 1. In the second equation, we have a slope of minus 1 and a y-intercept of 7. So the slopes are not the same. So we're going to sum that up by saying, and the way we say this, upside down therefore, is a since. So since the slopes are different, the system is independent and there is one solution. All right, let's have a look at the next one. We're going to do this one together. Now this one, of course, has a little more work for us, so we are going to manipulate these. So equation number 1, we are going to take minus 3y equals 5 minus 2x. I'm going to do a quick little rewrite on that just to get the negative 2x before the plus 5. I'm going to divide both sides by negative 3. And that gives us then y equals 2/3 x minus 5/3. Not too pretty, but also not too bad. So our slope then is going to be 2/3, and our y-intercept is going to be negative 5/3. So far, so good. Second equation is 4x minus 1 equals 6y. Now I'm going to do just a complete swap on this, and sometimes people are amazed when they see this, but I can just write 6y over on this side, and I can just write 4x minus 1 on this side. Because this equation is equal to each other, I can just start by taking the left side and the right side and swapping places with them, because they're equal, before I start transposing terms. Some people are amazed by that. You can totally do that in math. So there you go. 6y equals 4x minus 1. 6x equals 4, or sorry, that's not right. 6y equals 4x minus 1. That's much better. All right, I'm going to isolate y now by dividing both sides by 6. We have y equal 2. Now 4 over 6 can be reduced to 2/3x minus 1/6. Our slope is 2/3. Our y-intercept, negative 1/6. So let's step back and have a gander at these. So we have a slope in the first case of 2/3. Slope in the second case of 2/3. So these lines have the same slope. They're either going to be parallel or they're going to be right on top of each other. Let's take a look at our y-intercepts. Negative 5/3 and negative 1/6. So they have different y-intercepts, same slope. That is going to be a system that has no touching at all. So we would call this an inconsistent system. So we would say, therefore, I'm going to try to squeeze it in here. So since the slopes are the same, I'm writing fast and messy, and I apologize. Since the slopes are the same, but the y-intercepts are different, I really didn't leave enough space here. Therefore, the system is inconsistent with no solutions. No solutions. Spent a lot of time writing that. I should definitely have written that out in advance. Okay, so we have the independent system, we have the inconsistent system. I know what you're thinking, this one's going to be dependent. Let's find out. So again, we have 4x minus 2y equals 6. We need to reorganize these into slope y-intercept form to figure it out. Let's do that now. So I'm going to do a little rewrite here. There's my minus 2y equals, and I'm just transposing 4x over to the other side by subtracting 4x from both sides. Almost made a mistake there. Dividing both sides by negative 2. We now have y equals, so that'll be negative 4 divided by negative 2 is 2x minus 3. That gives us a slope of 2 and a y-intercept of negative 3. Second one, 6x equals 9 plus 3y. Again, just to get the y on the proper side, I'm going to write 9 plus 3y equals 6x. 9 plus 3y equals 6x. Let's make sure that's right. Yep, sounds good. All right, I'm going to start by transposing 9 over to the other side. So that's going to give me 3y equals 6x minus 9. I'm going to divide both sides by 3. That's going to give me y equal to 2x minus 3, a slope of 2, and a y-intercept of negative 3. So let's step back, have a look at these guys. So first equation, slope of 2. Second equation, slope of 2. So we get the same slope so far. First equation, y-intercept of negative 3. Second equation, y-intercept of negative 3. So these lines are identical. They're just sitting on top of each other. So I'm going to skip the since because I just want to get to the therefore part. I don't want to write as much this time. Good form, I'd write it out for sure, but I just don't want to keep you too long here. So therefore, the system is dependent with infinite solutions. Infinite solutions. Alrighty, there we go. So just to recap that, we manipulated the linear system, the equations in the linear system, into slope y-intercept form so we could more easily see the slope and y-intercept. Making comparisons of the slope and y-intercept allow us to determine whether the system is independent with the same with different slopes and one solution, whether it's inconsistent, which is same slopes but different y-intercepts that has no solutions, or whether it's dependent, same slope and same y-intercept. Last thing we're going to squeeze into this video is just given an equation, we're going to turn it or express it in slope y-intercept form and then write second equations that make the system either independent, dependent, or inconsistent. Let's start by manipulating this one right here. So we have 2x plus 7y minus 14 equals 0. We are going to transpose some terms so that we can get this into slope y-intercept form. Pardon me. So here we have 7y equals negative 2x plus 14. We divide both sides by 7. We now have y equals negative 2/7 x plus 2. Yikes, not very pretty. It has a slope of negative 2/7 and a y-intercept of 2. So there we go. Now if I wanted to create an independent system, what would have to be true of this? What would have to be true is that the slope in number 1 cannot equal the slope in number 2. They need to have different slopes. So again, I'm just going to make one up off the top of my head. Y equals just x. That works for me. That's 1x, so the slope would be 1. Different slopes, different y-intercepts. That's going to be an independent system for sure. If I were going to create a dependent system, this has infinite solutions. Essentially what I need to have here is the same equation over again. So I'm going to write that down. Y equals negative, is it 2/7? Yep, negative 2/7 x plus 2. The other way I showed you to do it is just to multiply the whole thing by a consistent value. If we were just to multiply it, say, by the denominator, which would be 7, that would give us 7y equals negative 2x plus 14. There we go. Both of those will work. That will create an infinite number of solutions in that the lines are right on top of each other. And last but not least, we have an inconsistent system. And if we're creating an inconsistent system, it means that the slope in the first one will be equal to the slope in the second one, but the b value in 1 will not equal the b value in 2. I guess I should have put that over here. m1 will equal m2, and b1 will equal b2. Has to be identical. Okay, but back to the inconsistent system that has no solutions. It has to have the same slope. So that'll be y equals negative 2/7 x with a different y-intercept. The original y-intercept was 2. We're going to make it 6, 5, negative 50. Doesn't matter, as long as the y-intercept is different. So that is how you go about using your knowledge of how two lines can interact on a coordinate plane to make, I guess, or to determine exactly how they're going to, how many solutions they're going to have and what those systems are called. That's the end of lesson number 2. Good luck with the homework, and we'll see you in lesson number 3.